Good evening, my 11th standard warriors. Welcome to the one-shot revision session of Kinematics 2D and Projectile with me, Shreyas, your physics master teacher at Vedantu. Looks like we have a farm or probably some nice animal breeding happening out here. Ankit has a lovely, a farm out there with lots of flowers and crops, and Nischal has a zoo. Very good. Congratulations. I'll definitely visit it one day. Hello Nishu, Ishpreet, Shabna, Jaya, Narmada, welcome Saja, welcome Kalyani, everyone. Hello, Crack with Gokulnath. Hello Jitesh, hi Sai Prasanna. This is Shreyas here, your physics master teacher at Vedantu, going live. And I have been teaching kids like you for a very long time. Yes, that's right. I left my corporate job like around more than 10 years back, and then I started teaching. And when my students started doing really well and many of them got 2-digit all India ranks, that's when I took up teaching full time. And ever since, there is no looking back. And I'm really proud that right now hundreds and hundreds of students have not just entered IIT. In fact, thousands would have entered NIT's bits under my mentorship, and I wish to continue doing so. And that's why I have come on YouTube, and there are very few channels which teach in English on YouTube. So that's why we are here. So guys, it's not just about English medium, but you get all the important updates, all the important notifications, and all the important preparatory notes as well as sessions that is needed for your preparation of all competitive exams like JEE, mains or advanced, KVPY, and any other things around it. So welcome aboard. And if you have forgotten to smash the like button, please do that right now. Hit the like button and do not forget to hit the subscribe button. Remember, there is a link for Telegram group. You can join it so that you get the PDF of today's session. Welcome aboard and happy Ganesh Chaturthi. Thank you for reminding it, Harini. I hope you had a great day. I hope you had lots of sweets. Happy Ganesh Chaturthi and Ganpati Bappa Moria. Yes, welcome, welcome, welcome. I'm pretty sure many of the students out here have had the Ganpati idol installation at home and had amazing lunches or sweets out there. Well, you can follow me on Instagram if you want to know more about me, and the schedule for this week is also going to be there in the PDF which will be uploaded on the Telegram group. So all the ones in blue are for 12th standard, the ones in red are for your 11th standard, and the ones in yellow are for NEET students on Biotonic channel. The ones in white are for JEE Advanced preparation. If you want to attend them, you are free to do so. All right. So our link is there for joining Telegram group. Check it out so that you get all the important updates in case there are any changes in the schedule, the PDF of the session, everything. All right. So let's get moving, guys, to our session. And we are going to start with 2D motion, and then we'll go to projectile motion, and then we'll end the lecture with inclined plane motion revision. Remember, detailed classes of this are also available in the Nurture series. Nurture is for 11th standard. In the playlist, I hope you know how to check out the playlist. Do check it out. Detailed classes are there for Nurture series for 11th as well. I'm very good at Spreet Mangat. Thank you very much. All right, so let's get going. 2D relative motion is already done, Sherlock. You can check it out. There are hardly, it's a very small chapter, 1D and 2D. So, relative motion. So check it out. It's again there in the playlist. I'm pretty sure you know how to check it out. Just when you go to our channel out here, you're all right. You just need to go to playlists and just go a little bit down out there. And when you go to JEE Physics, you will see all the chapters out there. So yes, 2D motion, relative motion. So in relative motion, there are 3 classes. You can see me conducting lectures out here. So 1D relative, 2D relative, and advanced questions on relative motion. It's all there. You can check it out. All right. Now we need to start with, hello, welcome all the new students out here. Hi Zaid, hi Siva Ganesh, hello Venki, hi Raju. So the first thing that you need to remember is resolution of vectors, because obviously that's the most important thing in 2D motion or 3D motion. You need to split any vector or like velocity or acceleration or displacement into individual components to solve the question. For example, if I have a vector like this and it's in a 2D plane, I will split it. Splitting is resolution, that's synonymous, into 2 vectors. The vector along x is called x component, the vector along y, is called as y component. Together, both of them give the same effect as that of the original vector. So these two individually together will give you the same effect as the total vector over here. That's why they are called as the split vectors or the resolved vectors or the components. Any vector is always represented as the x component I cap, y component j cap. There could be also z component k cap if there was z axis and this vector was in 3D. If it was out of the plane of the board, then you can also have z component. And what are these I, j, k? I is a unit vector in x direction. So if you go 1 unit in x, that is I cap. If you go 1 unit in j, that is, or y axis, that is j hat. So you have gone ax times I hat, ay times j hat, and that together will give you the total vector. Remember, this is actually bar, but probably you cannot see the bold. That's why I've mentioned the bar explicitly out here. Now, if you want to find the magnitude of the vector, magnitude of any vector is modulus. That's another way of writing it. Or just a, without making it bold, it will be nothing but the x component square plus y component square under the root. Pythagoras. Magnitude means length of that vector. So it's basically the length of that vector. Example, if I ask you speed, speed is the magnitude of velocity vector. Speed is scalar, velocity is vector. So the magnitude of instantaneous velocity will give you the instantaneous speed. Everybody getting it? Alright. So Nishu, there are other problems on black screen, especially for physics, because there are lots of diagrams which need to be added, and when you add those diagrams it becomes haywire on black screen because most of the diagrams have a white background, so that becomes a problem. But I have kept it in mind, maybe someday when we have really amazing graphics one day, that time probably I will love to do it. But otherwise you can also watch it in the inverted mode or dark mode on your mobile phone. Alright, clear. Now next thing is that unit vector. Unit vector is basically a vector which is along some other direction and it has a magnitude of 1, and the definition is the vector itself divided by magnitude. You should know this. Very straightforward, guys. Unit vector is nothing but vector divided by magnitude. Standard definition, do not forget that. Alright, now having said this, let's also look at 2D motion, because once you talk about resolution, we should also talk about 2D motion. Now what exactly is 2D motion? Look at this particle. Don't you see this particle is doing some motion in two-dimensional plane? Now if you look at the x coordinate, look at the x coordinate, and if you look at the y coordinate, they are doing 1D motion. So in a way, a 2D motion is two one-dimensional motions. I hope that makes sense. So two one-dimensional motions is making up a 2D motion. So if I want to study a 2D motion, all you need to do is, you can use kinematic equations, but you will have to use it separately for x-axis separately, like over here, and y-axis you'll have to use it separately. So you can use kinematic equations in x and y direction separately to make sure that you analyze the motion completely and independently. There is only one catch when you use these kinematic equations. What is that single important catch? That catch is nothing but the acceleration ax and ay should be constant. In both the directions it should be constant. Well, you might be like, sir, what if it is not constant? Well, you know what to do if the acceleration is not constant. Yep. When the acceleration is not constant, all you need to do is make use of derivatives and integration. So from x, you can go to x velocity and x acceleration by differentiating it. So dx by dt will give you x velocity, rate of change of x velocity will give you x acceleration. Similarly, y coordinates derivative of y coordinate will give you y velocity, and the rate of change of y velocity with the time will give you y component of the acceleration. As simple as that. Is that clear? Yes, Varlina, you're probably a little bit late. Classes start at 7:30, sometimes at 7. So please join the Telegram group, guys, so that you do not miss any of our classes notification, and also hit the bell icon. If you go reverse on the top, we all know you need to integrate it to go on the top. So keep this in mind. Alright, now let's solve some questions so that you can get a better feeling of how exactly to solve two-dimensional questions, and I have collected some excellent questions for you guys to understand this concept. Here is the first question coming up on your screen. Great. Chalo, hello knowledge facts, welcome aboard. Now, a particle has initial velocity of 3i cap plus 4j cap and acceleration of 0.4 i cap plus 0.3 j cap. How much will be the speed of the particle after 10 seconds? Let's see. Very good, Anish. I'm so glad that you will be here. Good decision. Hello, Swati. Welcome aboard. Ankit saying already B. Okay. I don't know. Let's figure this out. Come on, my warriors. Yes. Come on. Think about it. Oh, Anish, you are recollecting the similar slide? Well, remember, this is a one-shot revision session. We have done extensive, detailed classes separately in 2D motion, projectile motion. Remember, some weeks back, some months back. So yeah, probably you might recollect similar things. So remember, this is revision, but the problems are different. Okay, let me tell you that. Yep, I'm not using the same problems. Okay, B. Everybody's saying B. Let's try and do this. How are we going to solve the problem? We have to find the final speed. Speed is magnitude of velocity. So final velocity is initial velocity plus acceleration into time. So what is initial velocity? That's 3i cap plus 4j cap. Acceleration is 0.4 I cap plus 0.3 j cap, but it is 10 times. So this will become 3i plus 4j plus 0.4 into 10 is 4i plus 3j. So 3i plus 4i, 7i, 4j plus 3j, that's 7j. So that's final velocity vector, but the magnitude of that velocity, that will give you the speed, and that will be root of 7 square plus 7 square, which is 7 root 2, which is option B, guys. Excellent. Proud of you. Very good. Excellent. Very good. Okay. Let's get moving. Attendance mark Gauri Shankar, and stay tuned till the end of the class, my warriors, and keep marking your attendance by answering the question so that I know you guys are here. Yep, very good. I feel very happy when you guys attend my classes. This is a brilliant question. The next one that is coming up on your screen. Sure, Crack with Gokulnath, you can definitely ask whatever it is. If it is related right now, I'll answer it, or else probably you can leave it in the comment section. I'll definitely answer it. Okay. So yeah, Kalyani, I saw your comment last time. I mean, she was pleading all the 11th standard students, please come on 11th standard students. She was motivating, like, come on, buck up. We need to work really hard, because 10th, 9th and 8th standard students are doing so well on this channel. Although I'm very proud of these students from 8th, 9th and 10th. But 11th standard students, come on, you need to up your game and make sure you do not lag behind. Yes, because the competition is going to be really tough now. Alright, the particle is moving with some speed where k is a constant, the general equation of its path. Now the meaning of the word path is, you should have y as a function of some x. No time in it. Time should not be there. Okay, time variable only should not be there. Let's see. Akash, I'm from NIT Nagpur, bacha. Oh, Raju, good, your college is opening, but don't worry, evenings will be free for you. So what we do now? Acha, this is the velocity where k is a constant. Okay, now any velocity is nothing but vx I cap plus vy j cap. Now over here, by comparing, you can clearly see what is vx. Vx is ky. And what is vy? Vy is nothing but kx. Correct? Everyone fine? Just compare. Velocity in general will be something I cap plus something j cap. Two components. Compare. Vx is this. Vy is kx. Alright. Now what is Vx actually speaking? Rate of change of x coordinate. So Vx is nothing but dx by dt, that is nothing but ky, because Vx is dx by dt. What is Vy? Vy is rate of change of y coordinate. So this is dy by dt is equal to kx. Now what did I just say? Y should be a function of x, time should be eliminated. There is only one way I can think I can do this, and that is divide both of them. Yes, just divide both of them and see what happens. So dx by dt upon dy by dt will be ky divided by kx. You can clearly see what happens. K goes, dt also goes. So therefore I'll be left with x dx cross multiply is equal to y dy. Everybody fine till here? I just cross multiplied. Time has been eliminated out of the frame, out of the equation, it's gone out. Now the next step will be integrating both of them. So integral x dx will be integral y dy, and I will get some constant of integration. So this will be x square by 2 is equal to y square by 2 plus some constant, correct? So I want it as y square is equal to something, or y is equal to something. So y square by 2 will be x square by 2 minus constant. So multiply by 2. So y square is equal to x square minus 2 times of constant. This can be also written down as y square is equal to x square plus some new constant. Okay, this is some new constant. That's it. So this is the generic form, which is option D. Very good, Saja. Excelente. Okay. Yes. No problem, Ankit. Happens. Yes, Siva. Yes, Svarlina. Correcto. Yes, correct knowledge facts. Yep. What a brilliant question. Yes, what a brilliant question. Yes, by the way, x can be also a function of y. There is no hard and fast rule that y has to be a function of x. Even if there was an option saying x is equal to, or x square is equal to y square plus constant, that option also would have been correct. Okay, but there is no such option like that. You can see there is no y square, there is no x square. So had there been an option, that option would also be correct. Okay, so what a brilliant question, guys, where we had to eliminate time out of the equation. Let's move on. Option D was correct. Beautiful question coming up on your screen. So yes, streaming Tamilian, you can definitely get the entire lectures separate. There were 3 classes on 2D motion separately, not just relative. Relative, there are more 3 classes. Just 2D projectile motion, there are 3 classes. So you can check it out in the playlist of our channel, Enthuse channel. Go to playlist, go to physics. You will see chapter wise playlist. I'm pretty sure you will be able to do that, bacha. Okay, do that. All right. Yes, मेरे house में गणपति आता है, but वो पुणे में आता है, Bangalore में नहीं, because one house should have one गणपति. Okay. How to come to this intuition? By solving problems, Anish. Number 1. Number 2, I had already mentioned when I taught you 2D motion that whenever you see the word path, trajectory, it always means y as a function of x. And you can see in the previous question some variables were there. So that means derivatives and integration will be there. Also, I need to get rid of time. So once I wrote it in derivatives and I saw dt and dt, it immediately clicked. Oh, let me get rid of dt by dividing them. So that's how it should come, intuition. Okay. A particle leaves the origin with an initial velocity, acceleration this much. When the particle reaches maximum x coordinate, what is the y component of the velocity? Remember, any 2D motion is nothing but 1D motion in x and 1D motion in y. As simple as that. Let's see. Okay, now let's see what do we do. Oh, thank you, Ankit. My Hindi is very good, it seems. Okay. Yeah, I forgotten how to talk properly in Hindi thanks to teaching in English. है ना, अगर मेरे को अभी कोई बोलता है चलो सर आप हिंदी में पढ़ा दीजिए, so you know I have to think, अच्छा what is that word for this? Anyways, let's see how to solve this question. You have initial velocity of 3 I cap meters per second in the x direction. You can see I cap means x. So only consider x direction, reason being it reaches its maximum x coordinate. What does this line mean? Let's try to understand. Initial velocity in the x direction is 3 meters per second. Acceleration is -1 I cap. That means this acceleration that you see over here is towards the left side. What happens when acceleration is opposite to velocity? Obviously the speed reduces. Obviously the speed reduces. And eventually you will see the speed reducing, and eventually it will become 0. Velocity in the x will become 0. And that's when the particle will reach maximum x coordinate, because it will stop over there and it will come back. It will accelerate backwards. So don't you see, this is the max x coordinate. Did you just see that? This is how you should use your brain. You should visualize. Acha, the x coordinate will only increase till it stops, because after that it's going to turn back and accelerate backwards. So that's the max coordinate. Cool. So let's try to solve this question. Velocity finally is 0. Initial velocity is 3 plus acceleration is -1 because it's opposite into time. So that time is 3 seconds. So at 3 seconds, the x coordinate is maximum. Now what do you need to do? The question is, what is the y component? Oh, that is simple. Just think about it. What is initial y velocity? Initial y velocity is 0 because only I component is given or x component is given initially. So initial y component is 0. Acceleration in the y-axis, is that given? Yes, minus 0.5 meters per second square. And lastly, what is the y component of the velocity? Acha. So I will say Vy is uy plus ay into t. Uy is 0, ay is minus 0.5, time is 3 seconds. So this will be minus 1.5 meters per second, which is option C, I believe. Check this out. Did you guys get it? Understood? Clear? What a brilliant question. Got it, says Alan. Very good, Raju. Excellent. Yep. So the concept over here was to split x and y separately. Understanding what maximum coordinate means, for that I drew a diagram. From that I inferred, oh, when the x coordinate is maximum, it has stopped and it will turn back. From that I found the time. Once I get the time, I'll use the time to find the y velocity. That's all, using kinematic equations. Acceleration was constant, remember that. That's the reason I've used kinematics. If this acceleration was not constant, I would have to switch over to derivatives and integration. All right, beautiful question. All right, let's get moving. All right, Kamlesh, it's C, correcto. Now let's go to projectile motion. Although you can also see projectile motion from here. So I'll tell you where you can see it. There is this FET, there is this website out here. I hope it opens up. Yep, this has got beautiful simulations out there. It sometimes takes time to open up, and especially when you want to show it, it will take extra time to embarrass me. And it has got beautiful simulations, and let's see if we can find the simulation for 2D motion. Yes, projectile motion, there we have projectile motion, and let's just open this and see how it looks like. Very, very interesting simulation, and it's going to take extra time. Very good. Where is it? Please open. Yep, it's opening, it's opening, it's opening. How many of you know this website, by the way? If you know this, do let me know. How to see my HC Verma video in Vedantu? Zaira, you can do one thing, bacha. Just on YouTube, search one thing. Shreyas Sir Pro subscription. Search that, you will get one video. Shreyas Sir Pro subscription courses. In that I have explained in detail how to find each and every course of mine on Vedantu, including HC Verma, derivations, problem solving, Erodo, all these courses you can find. Okay, so let's just go to the lab part. All right, there we have. And you can adjust the different parameters like gravity and all of that. But I don't want air resistance. So this was air resistance. Okay, it's gone. And let's just shoot this cannon and see what happens. Beautiful. It just gets shot over there and it falls over here. So it has fallen somewhere over here. Now this was 80 degrees. Let's try to change the angle and make it something like 70 degrees maybe. Okay. Okay, so let's shoot this and see. Oh yes, the range increases. This is projectile motion. A motion which is happening under gravity is called as projectile motion. If you want to look at the different parameters out there, well, I guess I'm not able to see that right now. But anyways, No problem. So now if I try to change the angle to 45 degrees, we all know that the range, oops, 45, please make it 45. Yes, there we go. And let's shoot it. You will see that the range will be maximum. It falls somewhere over here. Now the interesting part is, if you make the angle as 20 degrees, oh, I can't make it 20 degrees. I can make it only 25. If it is 25, the complementary of 25 is 65. So if I make the angle as 65 degrees, you will see that the range is same. You can see that. So for complementary angles, the range is same. Time of flight is different for different angles. In fact, it will be very large when the angle is more. It depends. The time of flight depends only on the y component. The range depends on time and the horizontal component. And I can show that to you over here in vectors form. That will be interesting. Look at the components of velocity and acceleration. I'll just show you. See, when I shoot this projectile, okay, see how it goes. And let's do this in slow motion. Look at this. The green one is the velocity. The yellow one is the acceleration. Look at that. The yellow one is the acceleration. Observe it. Velocity keeps reducing, becomes minimum, and then it starts increasing. The yellow one is the acceleration. Acceleration is always downwards. Look at that. Acceleration is always downwards. If I look at the components of this, look at the components of the velocity, the one in green, it's very interesting to see. The y component keeps reducing. The x component always stays as it is. Why is the x component staying as it is? The reason why the x component stays as it is because the acceleration is only in the downward direction. There is no acceleration in the x direction. So x velocity never changes. Keep this in mind. Is that clear, guys? So if I change the angle, obviously the x component will change because now the x component will be less. The y component will become 0. Remember one thing, at the topmost point, okay, at the topmost point, a lot of people think velocity is 0. Is the velocity 0? Observe this again. Is the velocity at the topmost point 0? No, velocity is still there, and that is the x component of velocity. The velocity is only least or minimum at the topmost point. Keep this in mind. Only the x component is there, y component becomes 0. So beautiful way to study projectile motion, and we have already derived all these formulas. So quick recap of all of them. Yep. On 90 degrees, somebody was saying, sir, please show 90 degrees. Will it burn itself? Let's see what happens at 90 degrees. Okay, 90 degrees, go, smash it, boom. No, sad, very sad. I thought it will burst and there will be nice fireworks, and like, this guy will run away or something looking at the explosion. Oops, no, nothing like that happened. Can we shoot this guy somehow? I don't know. Let's try and shoot them. Oops. No, this guy just, yeah, almost there, guys. I was just almost there. Probably I need to increase my speed little bit. 19 meters per second probably might just, I hope he does not remove his underwear and run away. Oops, he's just still standing there. He doesn't care. Like, yeah, I don't care. Cool, fine, no problem. He's emotionless. He's like a stone. All right. Cool. Anyways, let's get going. 0 degrees, unfortunately, I cannot do anything. Okay, so we have oblique projectile. Sindhu, we are planning something new for you guys very soon, but you can watch all my recordings right now in the vPro. Trust me, my recordings are as good as live classes. Okay, Sindhu? Okay. He was not a man, Ankit. Oops, that I'm not sure. Okay, let's not go there. All right. Maximum height is u square sine square theta by 2g. The maximum height is u square sine square theta by 2g. Time of flight 2u sine theta by g. Range 2u square sine 2 theta by g. Standard formula. Okay, very, very important formulas. And Muthukrishnan, just search for PHET. That's it. PHET on Google. What is y and x? I'm not sure, Kasinath. What do you mean by what is y and x? Thank you, Charan. Vinayaka Chaturthi. Very interesting name. And happy Ganesh Chaturthi to you too. And y and x. Oh, over here, these are the coordinates. Achha, somebody was asking, what is this y and x? Alright, these are the coordinates. So, at any given point of time, that projectile will have some y coordinate and some x coordinate. Y as a function of x is given by this equation. X tan theta minus gx square by 2 u square cos square theta. This is called as the equation of trajectory. This is the range equation. This is time of flight. This is maximum height. You should know all these formulas by heart, including this diagram of how velocity changes, which velocity becomes 0, when is speed minimum, and all these things. Time to go up, time to go down is the same. Keep this in mind. All right, cool. Oh, all right, sure, definitely, Kalyani. Sir, in the range, is there any extra 2? Yes. Oh, yes. My bad. Acha, guys, I'll get this corrected. Thank you for pointing it out. This 2 shouldn't have been there. If this 2 is there, then this 2 shouldn't be there, and there should be a cos theta over here. Thank you for pointing it out. Let me just check all the formulas once again. 2u sin theta by g. This is also fine. X tan theta minus half gx square by u square cos square theta. Now it's fine. Okay. So either you remove this and then you remove this. Yes. Thank you. Okay. Hi Raji Pratap Jadhav. All right. Cool. Thank you Aishwarya Gandhi for pointing it out. Okay. So I'll just get that edited in the slides which will be coming to you. Similarly, you have horizontal projectile. Unfortunately, I won't be able to correct because I think that's an image file. So when I have an image file, probably I cannot edit it. I have to give it back to my content team. They will edit it and it will take some time. Okay. So horizontal projectile, what is the idea? You are on a hill and you throw the object. It's like half the projectile, guys. I mean, that's it. So instead of throwing it from below and completing projectile, you are already on a hill and throwing it. So, you just have the horizontal velocity. Vertical component is 0 because you are throwing it horizontally. In that case, the time of flight is the same as the time for a ball which is dropped. If you drop the ball, okay, and if you see how much time it takes, this time and this time will be same because acceleration, displacement in the y direction is same for both these objects. Velocity of impact, that's the speed with which it hits over here. This is the velocity of impact. This velocity of impact. Okay, that will be both the velocities resultant. X velocity will always remain same. Y velocity will be root 2 gh. Think about it. Y velocity will be root 2 gh, standard formula. X velocity will be just u only. So square both these, add and put it under the root. This is exactly what you should get. Make sense? Yep. That's what it is. Lastly, range. The range where it falls. Where does it fall from the foot of the hill? That range is nothing but horizontal velocity multiplied by time. So you can see horizontal velocity is this. This is nothing but the time of flight. So horizontal velocity into time, the speed with which you go, what is your horizontal speed and how much time do you go? That will be the range. How far you go, range into time, speed into time. That's it. Okay, chalo, let's go to some questions. But before the questions, let me tell you guys, whenever you have doubts, please make use of the Vedantu app. In Vedantu app, there is a facility where you can ask any doubts by either texting to our doubt experts or taking a screenshot or a picture of your textbook or the problem where you are facing the doubt. Sometimes you might have problems like, sir, I don't know whether this method is correct. It's different from the solved examples method. So that time also you can ask these doubts. Take a picture, send it like this, and you can ask, what is the next step? Is this correct? Okay, now I understood it. So this is all free, and you can text them from morning till night, unlimited. There is no number on that key, only you can ask 5 doubts per day. Nah, nothing like that. So that's what the Vedantu in-app doubt feature is all about. So if you're a pro user, you will get this facility. It's all free, okay? If you're a pro plus or a pro classic user. All right, let's get moving. What's the difference between having pro and the doubt app and without having pro and using doubt app? Lakshan, I'll tell you what, the doubt app cannot be bought separately. It is a part of pro. Okay, so if you're a pro user, automatically you will get this doubt app. As simple as that. Okay. Are there any best colleges in India other than IIT? Yes, Ganesh, I have in fact made a video on that. Please check it out. Shreyas Sir, JEE Mains top colleges. You can search for it, you will get a video. I mentioned all the top colleges which you can get from JEE Mains which are not IITs. Okay. What is equal to 10 meters per second square? If G, I think G should be equal to 10 meters per second square, probably. Again, a misprint. So if G, obviously G is 10 meters per second square, then the horizontal component of velocity and maximum height respectively will be. Interesting question. Come on, let's see. Okay. Cool. Is this for student of subscription? Yes, knowledge facts. Yes. The Doubt app is all those students who get subscribed to us. Correct. Now, how do you do this question? Let's try and do this, guys. This is the projectile. This is my velocity. There will be horizontal and vertical components, and obviously there will be range, and this will be height. Okay. Now, having shown this, let's think about it. The range is given, time is also given. Horizontal component of velocity is asked. Guys, the horizontal component into time, speed into time will give me the range. So range is nothing but horizontal velocity multiplied by time of flight. So range is given to be 200, horizontal velocity is not given, time is 5. So therefore ux will be 200 by 5, which is 40 meters per second. So 40 is there only here. Maybe none of these is also possible. So obviously A is wrong, C is also wrong. I don't know, none of these could be possible if this data is wrong. So I need to solve it whenever none of this is there. Okay. Now the next thing that I will think is, what will be the y component? Yes, because time of flight is given. If time of flight is given, I can also find the y component, guys. Everybody, think about it. So the time will be 2 times y component by g. If you remember, it was 2 u sine theta. U sine theta is nothing but the y component, as simple as that. So this is nothing but 5, and this is a 2, and this is a uy, and this is a 10. So this will go off. So uy will be nothing but 25 meters per second. That's just the vertical component, but the question is height. Acha, what is the height? Height is uy square by 2g. Only the y component will matter for maximum height. X component, no matter how much it is, it will never matter in the height because it's in the y direction. So just standard formula, when you take a ball, throw it up, the maximum height reached by the ball is u square by 2g. So just use this over here. So this will be 25 square by 2 into 10. So that's going to be 625 divided by 2 into 2 into 5. So this 5, this will become 125. 125 divided by 4, 31.25. Just check this out, 31.25. Is it there? Yes, option B is correct. Correct. Yep, B option is correct. Understood how to solve this question? So very interesting thing over here is that, X component decides the range, Y component decides the height. And you can treat this projectile motion as a combination of 1D projectile motion, vertical motion, plus a horizontal motion. So you throw a ball up, it goes up and comes down. That's y-axis, and x-axis is a constant velocity motion. As simple as that. So option B is correct. Moving on, yes, option B. Next question, this you should get, guys. Glad you guys got it. Cracked it, Gopalnath says. Pakka. Very good, Swarlina. Very good, Kamlesh. Very good, Saja. Excellent. Very good. Come on, my warriors, figure this out. A ball is thrown up with certain speed at some angle to the horizontal. The kinetic energy of the ball varies in the horizontal displacement x as, come on. Rohan, it is too late, bacha, because that batch has gone already ahead. So unless you are okay with the lecture that you have missed and you are able to cover up the backlog, then it's fine. Else it will be too late. But you can still join, if you are okay with that. Achha, let's see how many of you can do this. Many of you are saying, some of you said D. Achha, interesting. When you throw the ball up, how does the kinetic energy change with displacement? Guys, this should be easy one. When a ball is thrown up with certain velocity at an angle theta to the horizontal. Guys, the answer is C, right? The answer is C. Yep, it is C. Why? Because initially the velocity is high, then the velocity becomes less, then the velocity becomes even less, then again it increases, and then again it increases. So you can see as x increases, kinetic energy decreases. Here the kinetic energy becomes minimum, and again the kinetic energy increases. So decreases, becomes minimum, and increases. It never becomes zero. Keep this in mind. At topmost point it is minimum, but it is definitely not zero because there is still some horizontal component left out there. Okay, very good. So that's the answer, guys. Option C is correct. None of the other options make sense. Okay, chalo, let's get moving to the next one. Oh, you guys have some lagging problem. I'm not sure why. Okay. Very good, Mickey. Got it, says Varlina. Next question. Let's see how many of you can do this within 1 minute. I'd be very interested to see the timer on, and yes, 1 minute. Two projectiles thrown from the same point at 60, 30 with horizontal. They have the same maximum height. What is the ratio of their initial speeds? Come on, my warriors. Okay, Anish, there is no lagging. Maybe some internet problem on some student side. Okay, there are still good 40 seconds left. You can solve it very easy. Use the formula. Maximum height ka. Come on, you will get it. Okay, Venki says 1. Complementary, yes, but it's not about the range, guys, it's about the maximum height. So be careful. Many of you are saying A. Aishwarya saying C. Jesus, you can just search for Shreyas Sir Pro subscription on YouTube. You'll get a video. Just check that video. I have mentioned how to find all my micro courses on Vedantu. Alright, so here is what you need to do. 60 and 30 degrees. What is the ratio of the initial speed? What is the formula for height? It is u square sine square theta by 2g. Now, according to the given question, h is same, 2 is a constant, g is also same. So therefore, u square sine square theta will be a constant. That means from this, u sine theta, if the squares is a constant, u sine theta is a constant. Therefore, u1 sine theta 1 is 60 is equal to u2 sine 30. And the question is initial velocities ratio. So u1 by u2 will be sine 30 is half, sine 60 is root 3 by 2. So 2 goes, so I'll get 1 by root 3. I think you guys made a calculation mistake. Some of you said 1, that's definitely not correct, guys. It is sine 60 and sine 30. They will not cancel. Okay, very good. The answer is D. Many of you made a mistake. No problem. Next question is coming up. Hopefully you will be able to solve the next question. Answer D. Here it is. Beautiful question on collisions now. Okay. Here is what is happening. You are throwing a projectile from here with speed v1. Simultaneously, you are throwing another projectile from here. Both these projectiles reach highest point over here and they collide or they just touch. So what's the condition for that? v2 by v1. What's the ratio? You throw this from here, throw this from here. The time taken for them to reach here is the same. What do you think is, v2 by v1? Come on, my warriors. Come on, think about it. Let's see how many of you can do this question. Come on. A projectile is thrown. Angle is also mentioned. v2 by v1 is asked. Saja saying C. Rutvik saying B. Interestingo. C saying Kalyani. Not sure. Swarlina also saying C. Okay, Anish saying B. Aishwarya saying C. Okay, one of you. Please remember it is v2 by v1, not v1 by v2. So be careful over there. it is V2 by V1. So make sure you have found out the right ratio. Some of you are saying A. Okay, so let's do this. EGL also saying A. Okay, so some of you are only correct. Let me tell you that. Now, for this projectile, okay, for this projectile to reach here, this is only the time taken to go up, correct? And for this projectile, it's also the time taken to go up, but you have to use different formula. What is the time taken to go up for this and the time taken to go up for this? Both of them will be equal. Why? Because they are colliding at the same time when projected from this, simultaneously. So projected simultaneously, both of them should take the same time to reach over here. All right. So what is the time taken to go up for this curved path? I know this. It is 2u sine theta by g is the total time. So instead of 2, just use u sine theta. So it will be just u. In this case, u is v1 sine 30 divided by g. Remember that 2 is not there, or you just multiply it by half. Okay, this 2 is going off. Similarly, time to go up for a vertical projectile is just v2 by g. So it is actually 2 times, but again multiplied by half because you just consider half motion, not the complete motion. So now it becomes simple because this g and this g will cancel, and therefore what will I be left with? Look at this. v1 sine theta is 1 by 2 is equal to v2. Therefore v2 by v1 is 1 by 2, which is option C. So all those of you who said C is correct. Okay. What is the meaning of OP? OP means overpowered. Yes, Shiva Ganesh, correcto. Sir, is motion is symmetric, then how time to go up is equal to time, how time up is equal to time up or doubt. So the motion is symmetric means the time to go up is equal to time to go down. That means each one of them will be total time by 2. That's the meaning of motion is symmetric. So that's why whatever was the total time, I have divided by half. So that's the only time to go up. But this, when I say, this is for this projectile, for motion of projectile 1. And that green part is for vertical motion of projectile 2. So the time taken to go up and time taken to go up for both these different projectiles is same. That's all I'm saying. I hope this is clear now. Okay. What's the difference between vPro and YouTube, Vedantu? Very interesting question. So basically, Sriram, what happens is on YouTube, I don't have control over the chats so much, although we have an admin and all of that, but the chats are more regulated. Plus, there is a second teacher on our Vedantu platform who is constantly solving all your doubts. Like right now, I am only solving the doubts, but imagine so many students, sometimes it becomes difficult, obviously. So, there is a separate teacher who is solving only doubts for all the students. Plus, there are quizzes, leaderboards, and whenever you answer, all those points get recorded so that after the class, you get a sense of satisfaction or completeness. Oh, I solved these many quizzes. And you can also track your progress. Not just that, you get your booklets, regular coaching booklets, you get recordings, you get micro courses preparation for KVPY. Not just that, you also get doubt solving facility, normal test series, advanced preparation, mains preparation, assignments after every class, assignments after every chapter, mock test every now and then, parent teacher sessions, guidance sessions, strategy sessions, and anything that you can think of that you should expect from a coaching. So that's what you get on Vedantu Pro. I hope I answered your question. Moving on to the next one. Okay. A body of mass m is thrown horizontally with some speed from the top of the height of a tower, and it touches the ground at a distance of 250 from the foot of the tower. Now this another body of 2m mass thrown with half the speed from a tower of height 4h will touch the ground at a distance of how much from the foot of the tower? Very interesting question, and let's try and solve this. First of all, if you have a tower of height h and this is the ground and you throw some mass, like this. It will go hit somewhere over here. Let's say initially this was 250 meters, or let's say I just call it as R over here. That's it. Okay, cool. Understood, says. Okay, let's see how to do this. Okay, great, Tansim. Some of you are already saying C. Now all you need to do is use the formula. Range is horizontal velocity, okay, into root of 2h by g. Now think about it. Mass has no role to play. Mass okay, does not affect acceleration due to gravity. So that information which is there, mass of 2m, mass of m, is just given to confuse you. That's all. They're just playing with your mind, nothing else. Now this is the range first time. Now if I just think about the range second time, let's try to think it. When I throw it at different speed from different height, the new range R1 will be, what is the new speed with velocity v by 2? Achha, this is v by 2. What is the height? The height is 4h. So this is 4h. So what will I get out of this? 4 comes out. So this will become into 2. Okay, into root of 2h by g. 2 cancels. So I'll get v root 2h by g. Interesting thing is this is the old range. So the new range is exactly equal to the old range. So that means the answer should still be 250 meters. This ground distance 250 meters should be the same. It did not affect it only. Yes, correct answer. Very good. Proud of you, my warriors. Saja. Very good, Aishwarya. Very good, Lakshmi Narsimhan, Swarlina, P, Chirspin, Xavier, EGL, that was wrong. Very good knowledge facts. Very good, Kalyani, finally. And excellent, Rudra. Very good. Proud of you. Let's get moving to the next question coming up on your screen. Beautiful question. Okay. Height y and distance x along the horizontal of a body which is thrown in the xy plane. Thrown in the xy plane is given like this. Y is a function of time, x is a function of time. What is the initial speed of projectile? Very good question. The equations are given of projectile in y and x, and they are asking you what should you what do you think is the initial speed of projectile motion? Let's give 1 minute for this question and let's see how many of the warriors are able to solve this. The data looks confusing. Trust me, it is actually a very straightforward question if you think independently. And then initial speed means what? Think. Initial speed will have 2 components. Probably that's why x and y are given. Come on, my warriors, figure this out. Everybody saying C. Okay. Trimbak, I don't know, bacha. At least the information I had till evening, results are not yet out. Oh, this type was asked. Very interesting, Rohan. Okay. Come on. Yes, net pucha hai, net. Yes, let's do this. Okay, and the time is 5, 4, 3, 2, 1, and there we go. Okay, so what you need to do is y is given and x is given. So how about differentiating it? So Vy will be dy by dt. Derivative of that will be 8 minus 5 into 2t, which is 8 minus 10t. Now initial means t is equal to 0. So Vy naught will be just 8 because 10t will just become 0. Similarly, x component of the velocity will be derivative of x with respect to time. Derivative of 60 is just 6. Oh, this is constant, so at t is equal to 0, the x component will just be 6 meters per second. Now you know the x component is 6, you know the y component is 8, so obviously this is the initial velocity, which will be root of 8 square plus 6 square, which is 10 meters per second. That's it. So option C is correct. Beautiful. Proud of you, my warriors. Excellent. Many of you got it correct. Lovely, lovely. So looks scary, but it is not when you do it by derivatives. So now you are confident. Guys, are you getting that confidence in derivatives? Slowly now you are like, oh, okay, fine. I can do this derivative. It's not that. Yeah, I can do it. Yeah, most of the questions you will be able to do. Now let's go to inclined plane. Oh, net pack. अच्छा, मैंने सोचा net velocity. देखो यार, हमेशा सोचता हूँ मैं physics के बारे में सोचता हूँ. Yeah, calculus is now a piece of cake, Siva. Very good. I hope that cake does not become very big so that the piece becomes very big. All right. Great. And it's become a piece of cake which you can easily eat. Glad. Thank you. Welcome, Anjali. Now, last topic. Inclined plane projectile. What is inclined plane? A lot of people think, oh, sure, inclined plane. Nothing. Guys, it's, it's like, imagine somebody kicked a ball. Okay, it's going like this. You jump and stop it. Jump and catch it. That's inclined plane projectile. You'll be like, what the hell? Yes, this is inclined plane projectile, guys. How? See, any projectile motion, if you stop it in between, I can just imagine, dream of it. Imaginary inclined plane. That's it. This is inclined plane projectile. That's it. So, a projectile which is stopped in between, that becomes an inclined plane projectile. It's just that you are not allowing it to complete the complete motion. This is called as up the plane because it's going up. There is obviously another version of it. You throw, it goes down like this. You stop it here. This will be called down the plane. That's it. Now you should be just well aware of the formulas. See, easy way to remember the formulas. First, theta. Theta is always measured with horizontal. So for example, I throw an object like this. Let's say this is 20 degrees and let's say this is 30 degrees. Example. Understand, my theta is not 20. It is 20 plus 30, which is 50 degrees. Look at that. Theta is the total angle. Okay, total angle. Alpha, that's the angle which the plane makes. So here alpha is 30 degrees. That's it. That's the first thing that should be embedded in your head. Next thing, no, the maximum range is not at 45 degrees. Be careful. Okay. Now, usually, what is your formula for time of flight? 2u sine theta by g. Do you see the formulas are very similar? Instead of g, you have g cos, and instead of sine, you have theta, you have sine theta minus alpha. So theta minus alpha is basically this angle. Okay, theta minus alpha is basically this angle. So this is your theta minus alpha. Okay. Similarly, height, usual formula, u square sine square theta by 2g. So again, instead of g, you have g cos alpha, and instead of sine square theta, you have sine square theta minus alpha. That's it. That's the formula you have. Range is how far from this point does it land. Okay, that will be, usual formula is 2u sine theta cos theta divided by g, usual formula. Instead of g, here you have g cos square, because you have sine cos, not two things, something like that you can remember. So you have 2 times cos or cos square. Okay, so instead of g, you have cos square. And instead of sine theta cos theta, you have sine theta minus alpha into cos theta. Remember, this is not cos alpha. If this was cos alpha, then this would have cancelled. So it is not cos alpha, it is cos theta. That's how you can remember it. Okay, everyone clear about it? Yep. And this is u square. All right. Last, oh, I messed that u square out here. Thank you. Okay. Maximum range formula. In normal projectile, you had it as u square by g. Instead of g, you have 1 plus sine alpha. G into 1 plus sine alpha. That's the only change. So these are the formulas you should remember for up the plane. Now don't remember down the plane formulas. Yeah. Look, sir, what are you saying? I should not remember. The questions won't come. No, the questions will come, but you don't need it. Why? Guys, when there is down the plane, there's only one change you need to do. What's the change? Wherever you see minus, put a plus. So you say minus, put plus, plus, plus. If you say plus, put a minus. The reason behind this, Ankit, is because you have not studied it properly from 1D kinematics. start from 1D, then go to 2D and see all my previous videos. You just jump over here and say, sir, I'm not able to understand. Hey, come on, you need to give it some time. Everything needs some time. EGL, you two have joined recently, bacha. This is a revision class. You cannot just probably come on the last day of dance practice and say, sir, I don't know how this step is. I'm just moving my hand here, but those people are moving their hands there. I don't know what's wrong with this. I just joined the class I was attending. Hey, you just missed the first few classes of dance. So that's why you don't know how to do it. So start from beginning. Okay, Saja will take as long as it might take, bacha, but it will be done obviously by November, December or January for 11th standard. Okay, cool. Let's move on. Down the projectile you can see all the things are similar. Theta plus alpha. Oops, this should be theta plus alpha. Mistake in the slide. I will have to correct it. And instead of plus, you have minus over here. Yep, that's how it is. Okay, so if your institute is good, then you can follow institute material. Else, use the recommended books. Okay, here is the question. Any trick? I just gave you the trick knowledge facts. Here is the, I just gave you. Relate it with, original projectile formulas and solve more questions from projectile motion. Then you'll get a hang of it. That's how you need to do. Okay, nahi to, see, these projectile formulas are very simple. You are just coming out of a pond. You were in a pond till 10th standard. You were in a small pond, and for you guys that pond was very beautiful. It had a lot of fishes, cute looking fishes, colorful fishes, and you were very excited looking at those fishes and those flowers around the pond. But you didn't know that the pond is not the only thing in the world. There is an ocean, there is a river. So you just come out of the pond and you are seeing new animals. You are seeing crocodiles, you are seeing, I don't know, big trees, you are seeing ocean waves, you are seeing mountains, and you're like, oh my god, what the hell is this? So yes, you're just getting used to it, bachalo. By the time you reach 12th standard, you'll be like, oh my god, I was just in this pond. How dumb of me. Oh, there was an ocean, there was a mountain. Oh, there was this giraffe, there was this elephant, there was this shark, there was this crocodile, and I didn't know about this. So it's going to take time. That's all. Alright. Class 12 to बहुत जल्दी हो जाएगा बच्चा. Okay, solve this question, guys, coming up on your screen right now. Anish, you can expect, definitely. Two bodies are projected from the same point with equal speeds in such a direction that they both strike the same point on a plane whose inclination is beta. If alpha be the angle of projection of the first body with the horizontal, then the angle of projection of the other is. Okay, let's try and understand what it means. हिंदी में बोला ना भाई, तू पहले हिंदी में बोला ना. ये कौन सा हिंदी है? हिंदी पहले तो मराठी मिक्स कर दिया तुमने हिंदी में. हिंदी में बोलिए ना, या फिर मराठी मध्ये बोला ना. ये तो कुछ अलग ही हो गया, हाइब्रिड वर्जन. Okay, so what is this? This is my inclined plane. Okay, and what is the angle of inclination? Inclination is beta. Okay, and I'm throwing a projectile like this. It hits here. This angle is alpha. Oops. Okay. Yep. If alpha be the angle of projection for the first body. Now, here is the thing. The second projectile is also thrown from the same point and it lands over there. I don't know what the angle is. Let's just take it something else later on. Now, most of you might think the angles will be complementary. Guys, the angles won't be complementary. Reason, the angles are complementary when the projectile is horizontal. Okay, you throw from the same point, it lands at the same level. This is inclined projectile, so obviously it won't be true, it will be something else. So what we do is start from the range equation. So the range formula are, because both of them will have the same range, keep that in mind. So it will be 2 into u square into sine of theta minus alpha. Here theta is alpha and alpha is beta. Alpha was the angle of inclination. That's how you should remember it. Okay. Into cos theta. Theta over here is alpha. Upon g cos square angle of inclination. Angle of inclination is beta. Acha. Now think about it. Since the ranges are same, since it's given in the question, okay, range is same. I have not changed the speed, so 2u square is same, g is same, plane is also same. So the product of these two numbers is same. Acha. So therefore, sine alpha minus beta into cos alpha is basically same for both of them. Okay, let's do something with it. I can just do one thing. I can multiply by 2 and divide by 2. The reason why I want to do it is 2 sine A cos B. There is a formula in maths. I would prefer converting it into that formula because I have alpha over here on both sides. Please remember one thing. Alpha and alpha, okay, these are my question marks, like variables. I want to find out for what angles is the inclination same. For what angles is the inclination same? Sorry, range same, my bad. What angles is the range same? So alpha is my variable. I don't like it like this. So how about using that? So I'll get, just take that 2 or just forget this half. Okay, just this is again a constant. So ignore this. 2 sine is cos B. Is 2 sine A plus B? Okay, sorry, it's sine A plus B, okay, plus sine A minus B. Everybody knows this? Sine of A plus B plus sine of A minus B. Everybody knows this? Alright. So what you can do this over here is just write sine of A, oops, what is A? A is alpha minus alpha, sine of alpha minus beta are both of them. Sine of alpha, 2 alpha minus beta, alpha plus sine of minus beta, sine of beta. Okay guys, I'm guessing you are not able to see me or hear me. Okay, chalo. Anyways, I will see you guys again later on. Alright, maybe there is some issue. Yeah, I'm there.